What's up, everyone? Today we're going to do a fun array problem, and what we're actually going to try and do is to figure out if an array includes a subarray that sums up to 0. So you can see in the example here that we have this sort of arbitrary array, and then this subarray here, obviously 2 plus 1 plus 2 equals 5, and then we have negative 5, so that sums up to 0. And in this particular problem, we're not worried about finding a specific subarray that sums up to 0. Just any subarray that sums up to 0 is totally fine. So let's go ahead and dive right in. The first thing we want to do is we want to figure out whether this is an array of integers or doubles or floats or something else. And the main reason for that is that it could actually affect our problem. If we have an array of doubles, for example, we can end up with weird little rounding errors, especially if they're very small numbers, where technically they should sum up to 0, but they don't. And we really, honestly, I don't want to have to worry about that. So we're just going to do this with integers. So it's going to be really easy for us to tell whether or not they sum up to 0 or not, because you can just do the math, right? So it's not going to be something that we need to worry about. So let's just dive right in and figure out how we're going to solve this problem. So there's a easy solution, right, which is to look at every possible subarray and then sum it up. So we could do that by doing some sort of double nested loop where we have 2 pointers, and we basically, let's look at what this would look like. We would use our 2 pointers, and we would basically we would go through all variations and sum up the arrays between the 2 pointers. So we would start like this, and then we'd increment to here, and so on and so forth. And then we'd increment the first pointer, and we would basically be computing what is the sum of this subarray, and that would go through all the subarrays, and that would be fine. That would take quadratic time, but we can do better than that. And of course, if we can do better than that, we want to do better than that. So let's think about what would be the property of the list so that we would know that there was a sublist that summed up to 0. And if we think about this, let's imagine that we're summing up let's just say that we want to sum up all of the elements in the list. So we get 1, 3, negative 2, negative 1, 1, and 0, like that. So, is that right? So, yeah, right. So we would get something like this, and we can go through the list, and obviously here we got a 0. So we could say that the whole list sums up to 0. And that actually makes sense when you look at this, because we have this sub array here, and then we have a 1 and a negative 1 in addition to that. So we would expect the whole list to sum up to 0. So that works. We can see that this sum is 0, but in a lot of cases that's not going to be the case, right? This is just a very particular example. So what other properties can we see in this sum that might tell us something about the list? And what I notice in particular is there's sort of a loop or a repetition of the same sum more than once. So you see there's a 1 here and there's a 1 here. And what that means is that when we went from the sum, so we had this sum here, and then when we added all of these up till this point, we ended up with the same value that we had before, which means that we had a 0 gain or loss from this sum here. So we know that the sum of these elements in the middle are 0, because otherwise these elements are 0, because otherwise adding these 4 elements to 1 wouldn't result in 1. So that's sort of the method that I think is going to make most sense, because we can do this in linear time, because all I have to do is compute the sum of all the elements in the list. So what we have to do is we're going to go through and we're going to sum all the elements, and we're going to look for if a sum is duplicated. And if the sum is duplicated, then we know that that is the end of our subarray that we're going to then extract. So let's go ahead and look at how we're going to code this up. So I'm going to return an int array. I'm going to actually return the subarray, but you could, for example, return the first and last index of the array, or you could just return the first index and a length or something like that. It's just in Java, this is going to be easier for me because I can't return multiple elements without returning an array, so I might as well return the array anyway. So, but you should check with your interviewer what they want you to return, because it may make a difference. So I'm going to call this zero sum, and it's going to take in an int array called R. And so what I'm going to do is I'm going to store all of these values, all of the sums that I get, and I'm going to map them to an index. And that way I'm going to know that way I'm going to be able to get back the index that I had at the beginning, so I'll be able to get my subarray after that. So what I'm going to do is I'm going to do a hash map of integers to integers, and I'm going to map the sum, the current sum, to the index when I last saw that sum. And that way I'm going to for each turn, I'm going to see if that sum is in the list, and if it is, then I'm going to get the previous index, and I now know the two bounds of my array, and otherwise I'm going to just add it to the hash map and keep going. So I'm going to do a hash map of integer, and I'm going to call it sums, and that's going to be a new hash map. And then what I'm going to do is I need to keep a running sum, right? So I'm going to say int sum equals 0. And now I'm going to go through all the elements in the array until I find a match or I don't. And we do also want to think about what we're going to do in the case that there is no valid zero sum array. So in this case, I think I'm just going to return null, but you might return an empty array, or you could return something else. Depends on what you're returning to begin with, what makes the most sense. So we're going to do for int I equals 0, I is less than r.length, I plus plus. And now we have the two cases. We have, if we get to the, if we find the sum, then we want to, or if we find the sum that we currently have already in our hash map, then we want to return the value, and otherwise we want to add it to the hash map. But we also need to be careful. It's easy for us to get a one-off error here depending on how the order in which we do things. So for example, if I have to decide whether I'm going to add the sum to the array first, and then if I'm going to add the sum from the previous turn to the array, or like how I'm going to count the sum basically. So am I going to do it like this, where the sum of this first one is 0, and then on each subsequent turn the sum is equal to the sum from the previous round? Or am I going to do it where I'm going to have the sum be like I had before, where the sum is like this? And it's going to make a bit of a difference in how we solve the problem. So what I'm going to do is I'm going to actually I'm going to get the old sum and compare it this way, so the result of this, which is going to be useful for us, and I guess you still have 0 at the end here, is that we're going to get the first index is going to be when we get the sum. So when we come to here, we're going to get sum, and the sum is 1. And then we're going to get this index, and we're going to have this index. And then when I output it, I'm actually going to use arrays.copy of range, or you could do it manually to actually copy the elements into a new array. But I'm going to use that, and it includes the first index and excludes the second index. So by using these two indices, I'm going to get this array, which is what I want. And so it's going to be slightly easier for me to do it this way in Java, but you can do it either way. You just have to be careful what you're doing and make sure that you're getting the result that you expect. So I'm going to say I'm going to first get the old index. So it's going to be sums.get sum, right? And then I'm going to say if it's null, then I'm going to just add my element to the array, and if it's not null, I'm going to add my element to the hash map, my sum to the hash map. And if not, I'm going to return a value. So if old index equals null, then what I'm going to do is I'm going to add my sum to the hash map, and then I'm going to increment my sum. So I'm going to say sums.put, and it's going to be sum and I, right? Because I'm mapping the sum to the index. And then I'm going to say sum plus equals r I. So that way I'm going to increment the sum the way I expect. And then Otherwise, I'm going to return the subarray. So I'm going to just say return, and you can do, again, you could do this manually. You could even write a small function to do it, but it's easier, especially if they like tell you they don't want you using the arrays library or whatever, which is kind of stupid, but you know, you never know. So I'm just going to use the arrays library because it's easier. So copy of range, and then I pass in the array, the old index, and I. And that's all there is to it, except that I need to make sure that I handle the case. So if we get through to the end and there is no sum, then I'm going to, and I haven't returned anything, then I'm just going to return null, because that's going to be the case in which it doesn't sum up to 0. Just like that. And at this point, you may notice that there's a little bit of a problem with this answer. And that problem is what we had here. If you imagine that we had this case doesn't quite work because we do have a sum, but let's imagine a case where the sum is the entire length of the array. And what we're going to end up here is that we're actually going to break out of this for loop before we get to the very end. Because what we're going to do is because we're incrementing the sum after we actually go through the round. So we're going to, when I is equal to r.length minus 1, we're going to add the last element to our sum, but we're never actually going to do anything with it. So we want to actually go back here, and it's good to pay attention to what you're doing, because you know, sometimes you realize that there's a little mistake along the way. But what we can do to fix this is just say we're going to add a greater than or is less than or equal to here. And then we also need to check that I is not equal to the length. Because if I is equal to the length, then this is going to crash. So what we're going to do is we're going to add an if statement here. And we're going to say if old index equals null and I is equal to r.length, then that's going to be our error case, right? So then we're going to return null and do an else if here like that. And if you didn't catch this right away, you can easily catch this by going through and checking your work. And that's the reason why we go through and we run through a couple examples, because we want to make sure that it works the way that we expect it to. And it's easy to have little bugs like that in it. So now that we did that, we still have to keep this return null at the end, because there's this case here where our compiler doesn't know whether it's going to definitely return a value or not. So we need to leave this at the end, even though we know we're never going to reach that. And then now this should work the way that we expect it to, because even if we get to the end, then we're going to check at the last, we're going to check either if it's null, which means that there's no result, or if it isn't null, then we're going to return the value that we expect. So let's go through and actually check our work and make sure that it works the way we expect it to. So I'll just use this example here. So I'm just going to represent our hash map here, and I'm going to keep track of our sum is going to start as equal to 0, and our I is going to also be equal to 0. And so let's just go ahead and start going through this. So we start sum equals 0, I is less than r.length because I is 0. We're going to, so old index is going to be equal to get sums, which is null because there's nothing in our hash map. So we'll come down, it's old index is null, but I is not equal to r.length. So we're going to come down to here where old index equals null, sums.put, we're going to put sum, which is 0, mapped to I, which is also 0, right? So, and then next we're going to increment the sum. So we're going to increment the sum in this case by ri, which is r0, so 1. So now sum is equal to 1, and now we're going to loop back, so I is equal to 1. And so let's go through again. In sums we get 1, which is null again. So we come here, we put sum and I, so 1 and 1, like that, and then we add R1 to the sum. So R1 is 2, so we get sum equals 3, and now we're going to loop back again. So I equals 2, and let's see so old index we're going to get sum of 3 now, which is still null. So we're going to say old index equals null here. So sum, we're going to put 3 and 2, right? So we're going to get 3 mapped to 2 like that. We're going to say sum plus equals ri. So sum plus -5. So that's going to be equal to -2. And now I equals 3. So let's do it again. We're going to get sum, which is -2. We don't have that in here. So we're going to come down. We're going to put sum of -2, 3, or we're going to put into sums. We're going to put sum and I. So that's -2 and 3, like that. And sum plus equals ri. So I is 3, which is this 1 here. So sum is now going to be equal to -1. And we're going to increment I, which is now 4. And so we're going to go through another time. We're going to get -1, which is not in our hash map. So we're going to come down to here where it's null, and we're going to put sum and I. So sum is -1 and I is 4. So we're going to put -1, 4, and then we're going to increment the sum by I4, which is this 2. So we're going to end up with 1. And now this is the last time through. We're going to come back and we're going to say that we're going to get sum, which is 1, and we see that that's already in here. So we get back old index is now equal to 1, and so we're going to come down to here, and we're going to return copy of range R, and then old index is 1, and the current index is 4. So we're going to do the copy from here to index 4, which is 1, 2, 3, 4, which is, sorry, the index should be 5 actually, because we forgot to increment it. So we're going to put our index is now here. So we're going to copy this range, which means that we're going to copy inclusively and exclusively. So we're going to copy to here. And that's what we expect. So yeah, that's basically it. Hopefully that problem made sense to you. It's a little bit tricky, but if you have any questions, let me know down in the comments or on the blog, and I will see you again soon.